All right, section 8.2, adding and subtracting rational expressions. So we're dealing with fractions with algebra expressions in there. And it's very similar to adding and subtracting just normal fractions. So if you look in the first couple sentences here, if they have like denominators, meaning the bottoms are the same. So if you notice here, number 1, number 2, number 3, you have same denominators. So this is really easy because it's kind of like if you had, 1/7 plus 3/7. When you have the same common denominator, you just add or subtract the tops, keep the bottom the same, and you're good to go. If they're not like denominators, you have to first find a common denominator, preferably the least common denominator, LCD, which creates a little bit more work. So when the bottoms are different, that's where it's a bit of a struggle. I will show you how to do those. So let's get rolling. So number 1, I know that I'm going to keep the bottom the same. And I just need to add the top. So 3x plus 2x, that's 5x. A negative 4 and a positive 5 is a 1. So correct answer, boom. Number 2, similar idea, except for here I'm subtracting. Now be very, very careful. I'm going to put a little star here. With subtraction, you got to be careful. I do know the bottom is going to be the same. But on the top, this is really 2x minus 1. Take away, you have to treat it like a parenthesis. And whenever you subtract through a parenthesis, you have to distribute this negative 1 through. So really you're going to have 2x minus 1, because distributing a positive 1 does nothing. But over here you're going to change those signs. So that's going to be a minus 4x and a minus 4 all over x squared plus 2. And now we got to combine like terms. So we're going to end up with 2x's and negative 4x. That's going to be a negative 2x. A negative 1 and a negative 4 is a minus 5 all over x squared plus 2. Now, if I could have factored x squared plus 2, I would want to factor that out. Or if I could factor the top, but I don't really see any opportunities there. So I believe the correct answer is just sitting right there. All right, number 3, again, same bottom number. I'm going to kind of speed this one up a little bit, where I just know I'm going to change all these signs. So I'm really just going to change this one, change this one, change this one. And I'm going to gather up like terms as we go. So 3x squared minus 2x squared. Well, that's 1x squared. Then I'm going to have a positive 3x. And then a negative 5 and a positive 2 is going to be a negative 3. And then I ask myself, is there any way to get two numbers times together to make a negative 3, add together to make a positive 3? I don't believe so. So I think this is as good as we can do, and we are done. It's simplified. Oh, one thing I did not do, identify any x values where it's undefined. Well, x cannot be equal to negative 3 because I will get a 0 in the denominator. Here, when does x squared plus 2 equal 0? Well, when x squared equals negative 2, and x squared can never equal negative 2 unless I do imaginary numbers, which I don't need to do here. So no x values make it undefined, so I'm just going to put none. And over here, when is 3x minus 1 going to equal 0? Well, it looks like when x equals 1/3, that's where we're going to have an undefined expression. So I kind of forgot that little part. Now, least common multiple, LCM. So to find the least common multiple, you want to factor them first. Always factor each one. Write any repeated factors as powers. So for example, you have the expression on the left, but when you factor it, you'll get x, and then you'll get x plus 3 times x plus 3. You just want to write it as x plus 3 squared. Because when you list out the different factors, if they have a common factor, you want to use the highest power. So I'll kind of show you that as we're going through. So on this first part, it just says, hey, find the least common multiple for each pair. So let's just do it. Well, the first number that 2 and 3 both can go into would be a 6. All right, so that's the LCM for 2 and 3. And if you're ever stuck, you start counting by 2s. Then you start counting by threes. And the first one that they share, that's the least common multiple. All right, so for this one, it'd be 6. Now, if you have x to the third and x to the fifth, this is where you are going to do the highest power. So x to the fifth would be the LCM for the x's, y4, y3, y to the fourth. So that is the first chunk that both of those can go into. So moving on to number 5, I have 2 terms. So let's factor these both because that's what it says. It says, hey, factor each one completely. So this would be an x plus 4 and an x minus 1. So I have those 2 factors. Over here I have an x minus 2 and an x minus 1. All right. So basically I have 3 different factors here. I have an x plus 4, an x minus 1, and an x minus 2. This one over here is just a repeat, so I don't need to include it twice. So x plus 4, x minus 1, and x minus 2, that would equal the LCM. Now, if I wanted to, I could multiply all those out and get an x cubed expression, but we don't really need to. And you'll kind of see where this plays in a little bit later. So now we need to get to the nitty-gritty. Now we need to add 2 fractions with different bottoms. So first step is I got to get an LCM. So I'm going to leave the top the same. I'm going to do the bottom. That's going to be an x plus 2 and an x plus 1. And then over here, I have an x plus 1. So in order to get these 2 bottoms the same, what I need to do is they both need to have this x plus 2 in the bottom as well. Because my LCM would be x plus 2 and x plus 1, because those are the only 2 factors that show up there. And I'm missing the x plus 2 on the right. So what I'm going to do is I'm going to multiply by x plus 2. That'll give me the bottoms to match up. But whatever you do to the bottom, you have to do to the top. You know, really what I've just done is I've just multiplied by 1, which doesn't hurt anything. All right, so let's go through and let's rewrite this out. So when you add 2 fractions, the bottom numbers stay the same. And now I got to put the tops together. So I'm going to have x minus 1 plus, and over here I kind of need to clean this part up. Like I need to multiply that out. Well, that's x squared plus 2x. And then I'm adding an x minus 1 to that. So it looks like I'm going to get x squared plus 3x minus 1. When I combine, you know, my like terms from up above, this x can go with this. And he's his own person. He's his own person. And then I want to see if at the very end I can factor and cancel something out. But I don't think that top is factorable. So I think we're just going to roll with that answer right there. All right, number 7. Looking at number 7, I need to try to figure out what is the LCM of the 2 bottoms. Well, first thing I want to do is I want to factor this one to the right out. And that's an x plus 3, x minus 3. On the top I have negative 18. So it looks like my LCM is, when I look at the factors here, it's x minus 3 and x plus 3. So I'm missing that from over here on the left side. So I need to multiply an x minus 3. And if I do it to the bottom, I have to do it to the top, multiply by 1. So cleaning this up a little bit, I got to distribute over here. So I'm going to have x squared minus 3x added to a negative 18, which is really just subtract 18. And then the bottom I just keep the same, x minus 3, x plus 3. Now the only thing I want to double check is I want to see, could I find 2 numbers that make the top? And I believe that I could. You know, looking at negative 18, You know, that could be 1 and 18, 2 and 9, 3 and 6. I think 3 and 6, if I play my cards right, would factor into that. So I'm going to rewrite this top as x plus 3 and x minus 6. And on bottom, we have an x minus 3 and an x plus 3. And this kind of goes back to section 8.1, where I'm allowed to cancel factors on top and bottom. So at the end of the day, final answer is just x minus 6 over x minus 3. And that will be it. We'd be good to go. All right. Moving on down. Now we're going to do subtraction. Same game. We just got to be careful on the top to distribute that -1. So let's rewrite this one. I'm going to factor the top. That's going to be 2 times x squared minus 8. On bottom, that factors out to be x plus 2, x minus 2. And then we take away an x plus 4 over an x plus 2. Notice what we're missing. We are missing this x minus 2 in the denominator. So I'm going to multiply this side by x minus 2, multiply the top by x minus 2. So let's work this whole thing out. And, you know, it looks like I really didn't need to factor out that top because nothing's going to end up canceling with it. So I'm going to kind of do a little something here. I'm going to rewrite that back as just 2x squared minus 16. Now, this part over here, I need to multiply this part together first. So let's kind of come over here and let's do that. That's x squared plus 2x minus 8. But remember, I'm minusing through that parentheses. So when I minus this 2x minus 16 and I take away all that stuff, I need to distribute that negative, which is going to give me a minus x squared, a minus 2x, and a positive 8. That's the top. The bottom is what it is. And now we got to kind of clean up that top and see if anything can happen here. Well, 2x squared minus x squared, that's just x squared. I have a negative 2x. So far I've taken care of him. I got a negative 16 and a positive 8. That's a negative 8. All over x plus 2, x minus 2. Could we factor the top? I think we can. I think I can factor that top into x minus 4, x plus 2. In the bottom, I have an x plus 2 and an x minus 2. Luckily, we do get another cancellation. End of the day, final answer, that right there. So a lot of factoring, a lot of combining like terms, a lot of doing a bunch of stuff to get it to work out right. All right, moving on along to number 9. This one's kind of tricky because, you know, I have this piece and this piece. So those are the two factors. So my LCM is both of them. I got to list out all the factors. So I need that on the bottom. So let's kind of see what's going on here. So over here, maybe I'll write this a little bit different. So over here, I have 3x minus 2 over 2x plus 5. But for a common denominator, I need to multiply by a 5x minus 2. And on this side, I need to multiply by a 5x minus 2, because that's multiplying by 1. Over on this side, we already had 2 over 5x minus 2. Well, I need to multiply this side by the 2x plus 5. Over itself, you're always going to do it over itself. All these parentheses. And there's a lot of crap to gather up here. So So let's kind of do this chunk first, and then I'm going to do this chunk second, and then I will worry about distributing that negative. So let's kind of do those pieces. So let's just call this little piece A. Little piece A there, that's going to be 15x squared. It looks like it's going to be minus 10x minus 6x. So that's minus 16x. Then negative 2 times negative 2 is a positive 4. So I get that. So 15x squared minus 16x plus 4. That's on top. This is on bottom. And then we need to take away, I know the bottom's going to stay the same. And on the top here, I get 4x plus 10. All right. Well, now I'm going to handle the subtraction of the top. So I need to remember that this negative needs to get distributed through there. So to clean the whole top up, I have 15x squared minus 16x plus 4. That'll be a minus 4x and a minus 10. All right, well, cleaning all that up, I'm going to have 15x squared. That's going to be a negative 20x. And this is going to be a negative 6. All right, so I have all that going on top of 5x minus 2 and 2x plus 5. My bet is that the top is going to factor into one of those two, so I can cancel it out. This one's a lot of work. So we come through here, and we just kind of stay the course. And I need to try to factor this top out. Well, first thing I realize is there's no GCF. I can't really pull a number out of all those. So I'm going to use the bottoms up method. So let's go bottoms up. And I'm going to change that to x squared minus 20x. Now I multiply the 15 times the 6, and that's negative 90. Now I got to try to factor it normal. And how can I make 90? Well, 1 and 90, 2 and 45, 3 and 30, 4 doesn't go into 90, 5 goes into 90, what's that, 1 18 times, 6 goes into 90, 15 times, 7 doesn't go into 90, 8 doesn't go into 90, 9 and 10. I don't think any of those combinations there, I don't think that's factorable. I really don't see a way, as long as I did everything right, I don't really see a way to factor anything out. So I believe this is as good as it can get. I have to double check the answers to make sure that works out, but just first run through, I didn't see any things that can make 90 there that'll come out to be 20. You know, I got 21, 23, but nothing that really will do it for me. So I believe that's the final answer. Complex fraction. So complex fraction is basically when you have a fraction in a fraction. You know, so another way to kind of write this out is, if I wanted to write it out this way, I could say, hey, this is really 2 over x plus x over 4 divided by x plus 1 over x. But then remember, we really don't divide fractions. We multiply by the flip. So I'm going to keep this one. And then I'm going to change to multiply. Maybe I'll do that here. And then I'm going to flip it. And the nice thing about multiplication is I don't have to have common denominators, so I can just go straight across. But the problem is I do need to add that first. So in order to add that, I am going to have to find an LCM. And it looks like my LCM is 4 times x. So it's going to be, so I need a 4x on bottom. That's not too bad. I think I could multiply this side by 4 over 4. And I could multiply this side by x over x. And I'm going to get 8 over 4x plus x squared over 4x times, nothing needs to happen over here. It was that doggone addition that kind of created some work for me. And when I add these two together, this is just, x squared plus 8 all on top of 4x. So that's what the red turns into. And now I'm just going to multiply by this part. And let's just kind of go across and see what we get. Well, multiplying the top, I get x cubed plus 8x. And down here, I get 4x squared plus 4x. Now, I do see something that I could have done because this part is still factorable. So if I kind of come back over here, this part is still factorable. On top, I could yank an x out. I get x squared plus 8. On the bottom, I could yank a 4x out of there. And I would get x plus 4. And then I have this x and this x that can be kind of knocked out of there. So I think at the end of the day, I get x squared plus 8 over 4x plus 16. Or, I guess I could have left it as x squared plus 8, because that's not factorable. I think either one of these two, we would be good to go.